I'm Ms. Stevens. If you're studying functions and want to learn more about their attributes and develop a basic understanding of how they work, you're in the right place. This episode will focus on understanding the definition of a function, understanding how to properly use the phrase blank is a function of blank, and given a table of values, an equation in two variables, or a graph, determine whether it represents a function and explain your reasoning. I'll start by providing a short lesson and then walk through several sample problems. Let's get started. A function is the correspondence between a first set, called the domain, and a second set, called the range, such that each member of the domain corresponds to exactly one member of the range. In other words, for every input, there is only one output, and for every x value, there is only one corresponding y value. The definition of a function allows more than one member of the domain to correspond to the same number in the range. When defining a correspondence as a function, you'll often hear y is a function of x to emphasize that y depends on x. Let's work through a few examples together. Example 1. Determine whether or not each correspondence below represents a function. Here we have a set of values in the domain corresponding to a set of values in the range. -1 corresponds to 5, 0 corresponds to 3, 1 to 5, 2 to 11, and 3 to 21. Since each member of the domain corresponds to exactly one member of the range, this is a function. Let's try another. Is the president-elect a function of the election year? Let's recall our function code from above. Y is a function of x. In this example, y represents the president-elect, and x represents the election year. From the table, we can see that each election year corresponds to one and only one president, which makes the president-elect a function of the election year. It's okay that two different election years have the same president. That's allowed for functions. However, this doesn't work the other way. The election year is not a function of the president-elect because when we reverse the order, the new input, Barack Obama, corresponds to two different outputs, 2008 and 2012 election years. Let's try one more. Is the number of hours you and your classmates study a function of the final test grade? Again, remember our function code from earlier. Y is a function of x. In this example, the y is the number of hours, and x is the final test grade. Notice that two students got A's but studied for a different number of hours. The number of hours studied is not a function of the final grade on the test. If we flip it, the final grade isn't a function of the number of hours studied either. Two students studied for 4 hours and got very different grades on the test. When a correspondence between two sets is not a function, it may still be an example of a relation. A relation is a correspondence between a first set, called the domain, and a second set, called the range, such that each member of the domain corresponds to at least one member of the range. In the example we just did, the number of study hours versus the final grade would be considered a relation. Relations are sometimes written as ordered pairs. In this format, the x values represent the domain and the y values represent the range. For a set of ordered pairs to be a function, every x value has to correspond to only one y value. Example 2. Identify the domain and the range, then determine whether each of the following relations is a function. Okay, domain equals x values. So for these ordered pairs, I have 10, 10 again, you don't have to write it twice, and 7. For the range, I have -4, 4, and 7. Scratch that. For the domain, I have 10 and 3. For the range, I have -4, 4, and 7. In this case, the 10 corresponds to two different y values, -4 and 4. That makes this not a function. Let's look at another one. For this set of ordered pairs, my domain or x values are -4, 6, 7, and 0. Sometimes you're asked to put these in ascending order. If you don't have to, you can just leave it, but if you're asked, reorder them. The range is 9, 8, 0, and -1. I'm double checking my x values and making sure I don't see any repeats. There's only one -4, one 6, one 7, and one 0. No duplicates means that this is a function. We just learned that when one member of the domain is paired with two or more different members of the range, the correspondence is not a function. Let's extend that same logic to a graph. When a graph contains two or more different points with the same first coordinate, the graph cannot represent a function. There's an easy way to test this. It's called the vertical line test. If it's possible for a vertical line to cross a graph more than once, then the graph is not the graph of a function. To apply the vertical line test, we tried to find a vertical line that crosses the graph more than once. In this example, I can draw a line at x equals 3 and hit this graph easily more than once at 3, 5, 3, 2, and 3, -1. Since x equals 3 is paired with more than one member of the range, 5, 2, and -1, this graph does not represent a function. Example 3. Determine whether each of the following graphs is a function. All right, so for this first graph, I'll try to draw a vertical line and hit more than one point. Nope. Nope. And nope. So each time I try to draw a vertical line, I'm only hitting one point of the graph. That makes this graph a function. In my next example, I can draw a vertical line pretty much anywhere and hit more than one point easily. This is not a function. Let's try one more. Again, I can look at the graph, see pretty easily that most places I draw a vertical line, I'm going to hit more than one point. This graph is not a function. The vertical line test is an easy way to determine whether or not a relation is a function. If you're given an equation, a set of ordered pairs, or a table of values, and you're not sure, make a graph and use the vertical line test to determine whether or not you have a function. Now it's your turn. Pause the video after the next slide and try a few on your own. Example 4. Determine whether the correspondence is a function. Let's see how you did. For part A, we have -6, -2, and 2 in the domain. The range is composed of 36 and 4. -6 corresponds to 36, -2 corresponds to 4, and 2 corresponds to 4. Because each member of the domain corresponds to exactly one member of the range, this is a function. In part B, I'm looking at 5 ordered pairs. I know I have a problem if the same x value corresponds to more than one y value. So I'm looking at 6, -3 and seeing if there's any other ordered pairs with start with 6. There's not. How about -3? Nope. How about 0? Yes. I have 0, 2, and I have 0, 6. So because 0 corresponds to 2 and 6, this is not a function. If I wasn't sure, I could graph these 5 points and it would fail the vertical line test because 0, 2 and 0, 6 fall on the same vertical line of x equals 0. Try these two on your own. Okay, part C. I have a graph, so I'm going to use the vertical line test to decide whether or not this is a function. Note that that open circle symbol indicates that that point does not belong to the graph, but a closed circle indicates that that point is on the graph. Again, I draw my vertical lines, and anywhere on this graph that I draw a vertical line, I'm not hitting more than 1 point. So I'm good here, here, and here. This is a function. My last example is an equation. When in doubt, I'm going to graph this, but to graph it, I need to solve for y. So if I add y to both sides and I move 5 over, I end up with y equals 2x squared minus 5. I've taken a shortcut and already graphed this on my graphing calculator, so I can take a look at it. Here's the graph of y equals 2x squared minus 5. This is a parabola, and I can see that when I draw a vertical line anywhere on this graph, I'm only going to hit 1 point. So the graph of y equals 2x squared minus 5 is a function. For more step-by-step guided practice, check out the accompanying behind-the-scenes episode for this video. Remember that developing a solid understanding of math takes time and practice. If you liked what you saw today, please like, subscribe, and tell your classmates. Thanks for watching. I'll see you after class.